Hi everybody, welcome back to math. Today we are starting chapter 7. We are starting with integer exponents. So an integer is just a whole number, whether it's positive or negative. Alright, so our learning targets for this lesson, we want to evaluate expressions containing 0 and integer exponents. We are also looking to simplify expressions. Alright, so maybe we don't have a specific value for the variable, we can still simplify them a little bit. Alright, so for our warm-up, we have x cubed times y squared, where x is -1 and y is 10. So I'm plugging in 1, -1 for x, and a positive 10 in for y. Alright, now anytime I see a negative, I always put parentheses around it. Right, because otherwise if you do it in your calculator, it's going to give you the wrong answer. Alright, and then I have 10 squared. Well, I know 10 squared is 10 times 10, and that's just 100. But -1 cubed is -1 times -1 times -1. So we know that -1 times -1 makes a positive 1. But then we're multiplying it by another -1 to give us a -1. So really we have -1 times 100 to give us -100. So our shortcuts with negative bases for exponents, if it's an odd number exponent, it's going to end up negative. If it's an even number for the exponent with a negative base, it'll end up being positive, right? Because every even exponent is divisible by 2, and every grouping of 2 gives you a positive number, right? A negative and a negative makes a positive. So that's your group of 2. Alright, if we go on to number 2, we see 3x squared over y squared, where x is 4 and y is -7. So 3 times 4 squared over -7 squared. So order of operations tells me to do exponents first. So that is 3 times 4 squared. 4 times 4 is 16. All over -7 squared. -7 times -7 is a positive 49. Alright, so our last step is to multiply 3 by 16. That gives us 48 over 49. And we should check to reduce it. In this case we can't, so that is our final answer. Alright, so a couple things to remember. Exponents are all, you have a base and an exponent. Alright, so what is the base? Well, the base is multiplied by itself e times. Alright, so the base is what's getting multiplied over and over again. E, the exponent, that's the number of times that we multiply the base together. Alright, so the base is what is being multiplied. The exponent tells you how many times you multiply it. Alright, so we're going to fill out the rest of this chart. 2 to the 4th is 16. 2 cubed, remember that's just 2 times 2 times 2. That gives us 8. 2 squared is 2 times 2. That's just a regular 4. 2 times 1, so that's 2 one time. Right, 2 times itself one time. So in other words, just 2. Alright, now this one you might be a little bit confused by on your calculator. 2 to the 0th power. Alright, so a little trick. If you take any number and raise it to the 0th power, it is always 1. Right? Your base could be 1,000,000. If you do 1,000,000 to the 0th power, you're going to get 1. Alright, now all of a sudden we have a negative exponent. 2 to the negative first. Well, if we plug that into our calculator, it's 0.5. And 2 to the negative second, if we plug in our calculator, we get 0.25. Alright, now maybe you're starting to notice a pattern if you look down the table. But it might also help if I write it in fraction form. So 0.5 I could write as 1/2. 0.25 I could write as 1/4. Alright, so a couple of things we might notice is that if we're looking down, from the top down, our values are getting cut in half each time. If we're looking from the bottom going up, we would say our values are doubling each time. Alright, so the reason that is because in this case our base is 2. So we're multiplying by 2 each time. Alright, so you take 1/4, multiply it by 2, you get 1/2. Take 1/2, multiply it by 2, you get 1. Take 1, multiply it by 2, you get 2. 2 multiplied by 2 is 4. 4 multiplied by 2 is 8. And 8 multiplied by 2 is 16. Alright, we could keep going, multiply by 2 and find the next power. Alright, so we are noticing doubling because our base is 2. If our base was 3, let's say these were like 3 to the 4th, 3 cubed, 3 squared, then as we look up the table, we'd be tripling each time. Alright, so the rate of growth is all dependent on your base. Alright, so what do we notice when we write our answers as fractions though? Specifically, we have, let's see, 2 to the first is 2. 2 to the negative first is 1/2. 2 to the second is 4. 2 to the negative second is 1/4. So maybe you noticed it, maybe you didn't. Anytime you have a negative exponent, we want the inverse. So what I mean by that is if I had, let's say 2 to the negative 10th power, I could write that as 1/2 to the 10th. Alright? I could also go the other way. If I had, switch the colors up a little bit. If I had 1/2 to the negative 10th, well, what's the reciprocal? Let's just flip it upside down. So now the 2 to the 10th is above, and it becomes positive. Alright, so if you have a negative exponent on top, send it to the bottom of the fraction and make it positive. If you have a negative exponent on the bottom, you can send it to the top and make it positive. Alright, so the next page we'll do a little practice. Alright, I will do a couple of these for you, and then I will ask that you pause the video and try the last few on your own. Alright, so number 1, 3 to the 5th. 3 is our base, so that's what's being multiplied, and 5 is our exponent, so we're multiplying it 5 times. So 3 times 3 times 3 times 3 times 3. Alright, now that gives us 243. Alright, now I'm going to leave numbers 2, 3, 4, and 5 for you. Actually, hold on, I'll do 5 and 6. So if I do 5, 3 cubed, or 3 to the power of 3, is 3 times 3 times 3. That would give me 27. But number 6, I have negative 3 cubed. So since this negative 3 is in parentheses, that means that whole entire deal in parentheses, the negative 3, is what's being multiplied. So negative 3 times negative 3 times negative 3. 3 negatives make a negative, so negative 27. Alright, number 9. Alright, we will do this one together. Alright, so I'm going to separate this because the negative is not in parentheses with the 5. So I can treat this like a negative 1 times 5 to the negative 4th. Alright, so negative 1 times 5 to the negative 4th. And now remember, with negative exponents, I want the inverse. Alright, so negative 1 times, now the inverse of 5 to the negative 4th, 1/5 to the positive 4th. Alright, so I have negative 1 times 1/5 times 5 times 5 times 5. So really, this negative 1 that's out in front, that guy, that's just going to make our answer negative in the end. All right, so I'm going to kind of forget about it and just focus on our denominator. 5 times 5 times 5 times 5. So we would get 1 over 625. But don't forget we're multiplying by that negative 1, so it's negative 1 over 625. All right, so please pause the video and do the remaining 5 problems. And then resume the video when you're ready to move on and check your answers. All right, so check your answers with the ones that I got. Make sure we know what we're doing. All right, moving on. Now we are just simplifying a little bit, all right? We don't know what these variables mean, all right? So we just need to combine them and simplify them where we can. So number 1, 7w to the 4th x to the 0. So I know that anything to the 0th power is 1. So really I just have 7 times w to the 4th times 1. In other words, it's just 7w to the 4th. On number 2, I have 4 times x to the negative 2nd. All right, now the 4x is not in parentheses, so that negative 2 is only going with the x. So I'm going to rewrite this as 4 times, now x to the negative 2nd. Remember, we want to take the inverse, so 1 over x to the positive 2nd. All right, so just to make it a little easier, I'm going to write 4 as 4 over 1. So when I multiply straight across, I get 4 over x squared, and that is my final answer. All right, number 3 is a little tricky, so we're going to remember our shortcut to make it easier. All right, anytime I have a negative exponent on the bottom, I'm going to send it up to the top and make it positive. So that gives me negative 5 times k to the positive 2. Right? And that is my final answer. All right, if we didn't know that shortcut, we would have negative 5 divided by a fraction. And nobody likes dividing by a fraction because then we have to multiply by the reciprocal. And we're creating a lot of extra steps. So if we can just remember with negative exponents on the bottom, you just send them to the top and make them positive, it'll save us a lot of time. All right, now for these evaluating problems, we do have specific values for the variables. So x to the negative 1st, where x equals 2. So I know that x to the negative 1st is the same thing as 1 over x to the 1st. So now if I plug my value for x in, I get 1 over 2 to the 1st, which is just 1 over 2, or 1/2. All right, number 2, p to the negative 3rd. Remember, that's the same as 1 over p to the positive 3rd. So if I plug 4 in for p, I get 1 over 4 cubed. All right, and so 4 cubed gives me 64, so I get 1 over 64, or 1/64. All right, looks like we have a second number 2. One of these was supposed to be 3. Whatever, we'll call this one 3. All right, so for number 2, before I even plug my values in, I know that a to the 0th power, anything to the 0th power is 1. So no matter what my a value is, that's turning into a 1. And then b to the negative 3rd, I could write as 1 over b to the 3rd. So I have 1 times 1 over b cubed. In other words, just 1 over b cubed. Because multiplying by 1 doesn't change my value. So now when I plug in negative 2, I want to be careful because it's telling me my base is negative 2, so that needs to go in parentheses, the negative with it. All right, so this is 1 over negative 2 times negative 2 times negative 2. which is 1 over negative 8, so negative 1/8. Whether you have the negative on the outside, the 1 or the 8, it doesn't make a difference. Alright, and last one for the day. We have 8 times a to the negative second times b to the 0th. Well, I know b to the 0th is 1. Anything to the 0th power is 1. A to the negative second is the same as 1 over a squared, just taking the inverse. And then 8 is just 8 or 8 over 1. So really, I have 8 times 1 over a squared. I could multiply it by 1, but that's not changing the value. So remember, multiplying fractions, we go straight across. So 8 times 1 gives us 8. 1 times a squared gives us a squared. So now let's plug the value in for a. So we get 8 over negative 2 squared. Alright, now negative 2 squared is negative 2 times negative 2. So really we have 8, we have 8 over 4, and we know that 8 divided by 4 is just 2. So all of that just simplifies down to a plain old 2. Alright, so that is it for today's lesson. A couple things to remember. Be careful with negative bases. If you have a negative exponent, we want the inverse. So if you have a negative exponent on top or by itself, it's going to be 1 over. If you have a negative exponent on the bottom of a fraction, we can send it to the top and make it positive. And last little reminder, anything to the 0th power is 1. Alright, good job. This is a unit we will definitely need to practice, especially with the negative exponents. So take your time and make sure we know what we're doing. And if you don't be afraid to ask some questions.